Before we start with questions, I will mention that our panelists, Matthias from Siemens, he's the kind of guy that could answer a lot of questions about anything associated with operator training, virtual training, simulation of control systems, or simulation of processes, utilities, fossil, and others. Also, Eddie Habibi is working for a company, PAS. PAS is particularly expert at analyzing operating situations and have improved the alarming strategies for sure. At least I know that personally on projects that I've worked on in the past, that they could really come in and improve the entire alarming philosophy. And also, if you look at almost any industrial facility, I would point out that it's been my experience that the way the alarms got set in the first place was that at the factory acceptance test, when they shipped the control system, they asked, well, should I alarm this? Should I alarm that? And you know what? They alarm everything. All right? And so that means when the plant starts running, all of a sudden, there is a really lot of red alarms out there. And there are so many alarms out there that the operators cannot even figure out. They just ignore them and just say, there's just too many, I can't deal with that. I'm going to just look at my temperatures, pressures, levels, and flows and figure out what this process is doing myself. And that's where you get into these alarm rationalization programs. So in any event, with that introduction, I think you've heard the speakers, a very broad range of topics here. So I'm sure you could, might have some questions for them. Can we have a microphone come around?
Hi, I'm Rick Willett with LyondellBasell. I was wondering if y'all have seen anything in the area of operator training for drills in response to a cyber incident or cyber attack, if you've seen any of that. It's open.
So I'm Eddie Habibi with PAS. I haven't seen any, but that's a great idea.
And I'll add on to that. That is one of the use cases for the simulator that we're building is for operators to practice and what happens when they have an incident, how can they respond to it? Yep.
Actually, partly in response to that is having done the operator training simulators and talked to all the suppliers of all the operator training simulators and many end users, I have yet to see a training program that actually had very specific use cases for how to hack into a control system. And having designed and built those control systems on the bottom side, I basically could make that display look like any temperature, pressure, level, flow that I wanted it to, being very subtle. You saw the subtleties of the Stuxnet virus and how long it took for those operators to detect that their entire plant was hacked and their centrifuges were being overspeeded. This is the Iranian simulation with a PLC that was hacked into. Very sophisticated hackers, by the way, that completely understood the process, completely understood the configuration of the control system and the HMI, and devised a very carefully laid out plan. So if you have a hacker with that capability, I'm quite sure it will take a long time for the most familiar operator to actually detect it. But I certainly think that there are a number of things, and certainly we saw in some of the presentations that very careful version control. So make sure that the software that's getting loaded into the control system and the safety systems is not tampered with. We are going to put an MD5 checksum. We're going to determine exactly that this is the correct file, that file was made by the engineer, and at that moment it was loaded into the system, it was the correct file. And so all of this version control system is kind of part of the solution. Any other comments on security?
Yeah, the security topic, to admit, it's actually not a standard use case or scenario in training simulators. So typically, customer comes, want to have a training simulator, he describes the scenarios, fault scenarios, some hazard scenarios which you want to train. And the specifics, I think the very tricky part about that cyber attacks to be trained is what Rick just explained. How will it occur and how will it actually be displayed to the operator? Or because the attack should have the goal that on the HMI for the operator, everything should look fine. So how would he detect it? So it needs to be some thoughts how to define proper training scenarios, but you could also, technically, you could put it into a training system.
Just another comment. If you look at a cyber attack, it is not too dissimilar from an operator mistake, inadvertent mistake, or a process upset. At the end of the day, the attempt on disturbing processes at a plant that would lead to an accident happen at the configuration level. And the point here is really well that you have to manage that configuration. When someone comes from the outside and attempts to move molecules from one place to another to cause an accident, they will do the same thing that an operator would do when she is in a rush and makes a mistake. So the consequences are very much similar. So a simulator that is designed for operator training with various situations, mishaps, upsets, could very well be used. Because at the end of the day, the operator can care less how the hacker came in. What happens is the consequence. You have to be able to respond to the consequence, and a simulator is a great place to do that. Which brings up a really good point, and that I have to point out. I think there has been a lot of talk around IT-OT convergence, and this is both technology and people, but we still have silos. I think the industry is still being driven by IT people. This whole cybersecurity business is driven primarily by IT people, and they're getting all the oxygen or the attention, and you can't solve cyber attacks on the physical critical infrastructure from a SOC. Their job finishes once the incident happens. It's the operator and the operations team that has to recover. You can analyze the network all day, find anomalies on the wire, on the PCN wire, that may or may not translate into a physical event. But once it becomes a physical event, your threat intel guys sitting in the dark room monitoring the bad guys can do nothing to help the operator. That's where you need to have that well-trained operator who can take over and respond as if it was an incident, whether it's a simulated man in the middle, the UI not changing at all. The operator is used to that. The operator has seen incidents where she's lost view of the process. So I think the trained simulators are a great idea for that kind of training.
I think I have, sorry. The closest thing that we've had, really, Greg, is somebody that asked us to have the training system simulate total power loss in the plant, because they wanted to understand what would the operator be able to do and what would the process do by itself once it loses the connection to the operator. But that's as far as, and like I said, it's like something like he said, it's the consequence of, however the plant lost power.
Chevron? Well, that was loud. A question for DuPont. With all the good commercially available simulation software out, why do you choose to keep maintaining proprietary?
Ours is good too. No, it's what happens is we did not set out to create a dynamic simulator. Actually, when we first created that software, it was meant for teaching. It was meant to teach people the basics of control. And this is, like I said, in the early 80s. And the thing just started growing. I mean, suddenly people realized, hey, we don't have to just teach with this thing. We can use this to test control strategies. And then that went a step further. Then OPC came up and it became easy to connect to DCSs and was, we can do that too. And today, the software is so mature that it's extremely expensive to go to a commercial package. And actually that has happened with some of the spin-offs. they left DuPont, and now they needed to replace this, and they realized what they had. I think looking back, probably, and like I said, this is something that if I went to my boss today and I told them, oh, we need to create a dynamic simulator, they would probably won't, give me the time of day. But what happens when you have a software that is under your control, you can guide it. You can improve it in the areas that it needs to be improved to match whatever your company's needs may be. You're not supporting a whole market, you're just supporting yourself. And then the other thing is the turnaround in terms of adding or fixing things, because sometimes we get somebody will call us with a bug, and within a week the thing is solved. You don't have to wait for the next release of the commercial software the following year. So we got lucky in a sense because of how things evolve. But you're right. I mean, if you were today to start from scratch, you would look out and try to find what's the best fit for whatever your needs may be. Yeah.
Well, I'm actually glad she asked that question, because I was asking the same thing. We've seen a lot of end user customers in the old days, let's say, develop all of these kinds of functions themselves. There were some chemical companies that designed and built their own control system completely from scratch, all right? Because there was no vendors out there that would make a control system that could run our plant. If you look at the history of those kind of activities, there is definitely a trend to say that, no, we are good at manufacturing chemicals and that's our business, and the control system people have got a lot of skills. I think similar things in the area of simulation as well. Is there another question from the back?
Yeah, thank you. My name is Dave Alden from PAS. So my question is for Gilbert. I think that the approach you've taken to sort of farm out the synthesis of this alarm documentation is interesting. And maybe I'll piggyback on something that Richard said. I've participated in a lot of alarm rationalization myself. And yeah, there are a lot of alarms that get configured in these systems from scratch that aren't really appropriate, don't meet the ISA 18.2 definition of an alarm. And furthermore, I've seen that a lot of the alarm priorities that are configured from scratch are inappropriate also. So my question, Gilbert, is as you ask the operations folks to sort of put this alarm documentation, the alarm help, as you call it, together, did you also ask them to take it a step further and turn that into a different proposed priority where appropriate? Or did you sort of limit it to causes, consequences, corrective actions? And maybe as a follow-up, did you collect any data on how long that effort might have taken compared to the other ways you have maybe in the past developed that alarm rationalization content?
Yeah, that was one of the options early on, just do a full-blown alarm rationalization. But as anyone knows that's ever been in a full alarm rationalization, that time-consuming, it takes up a lot of resources, and literally it could be 6 to 8 weeks. In our case, our alarm performance is actually pretty good. So what we were lacking was in the documentation. Now, having said that, as the operators go through them, they did highlight some and say, hey, this trip limit's not right. That doesn't mean we change it. That just means we take that out and we rationalize it as a group. The other thing is when you're doing alarm rationalization, typically if you have the same people consistently there, you'll get the same consistent answer. That's not typically the case. Typically, they're trying to do this during a turnaround, and all your more experienced people are out assigned to the actual turnaround. So you get different levels of experience.
Just to follow up on that, were you able to use your simulators to determine alarm problems or procedures, or did you really try to develop these procedures, when you were executing them and seeing the alarms happen in the plant?
No, these are alarms that already exist. They just didn't have any documentation, but that is a good question. And we have talked to the training groups in the simulators saying, can we capture the alarms, the KPI, so we can gauge how the operator is doing during training, and just gives you another baseline to look at.
I have plenty of questions, so if you're running out, all right.
I'll make a comment, maybe create some questions or a conversation. One of the beliefs that I have had over the last 25 years is that the most important individual in a process plant, especially hazardous processes, is a control room operator. If your control room operator goes home at the end of the day without an event, the company has an opportunity to be profitable. But regardless of how well your engineers are, how great your technology is, how fantastic your CEO and your marketing people and procurement people are, if you have an event, you lose that opportunity to be profitable. So if we start with the operator in mind and look at the operator as the end objective person to be successful, as opposed to the traditional approach, I, as a control engineer, when I was putting in control systems, I wanted to see flatline on my control strategies. I wanted to see throughput increased. I would put DMC controller in the interest of improving the yield. And in every case, we overlooked the operator. I think the operator is the most important asset, but that operator has to be supported with the proper tools, just as you would not put a pilot in the cockpit of a 747 without proper education and training and refresher and rigorous ongoing tests. You shouldn't do that for the operator. The operator is the first person to identify an upset. She is the first person to respond to correct it. Take that as a safety measure, which we all understand, put the operator at the center of your universe, and then recognize that when bad things happen from a cybersecurity standpoint, from an outside attack standpoint, again, that operator is the one to be your first responder. So if we all keep the operator in mind and work on a few things that can help the operator, the competency of the operator, where the OTS comes in, the situation awareness of the operator, that is, as control engineers, we have a responsibility to make the alarm systems work well, the layers of protection work properly, your basic process controls, alarms, SIS, and then the PRVs in place. And finally, create an environment where this operator is not disturbed. I've been to control rooms where it's like a hallway. People are coming and going. So, and just one more note. This morning on the news, I heard that today is NASA's Remembrance Day, remembering the astronauts over the last 40 plus years, who lost their lives with Apollo 1. 3 of them died in Apollo 1 incident, and then the Challenger and Columbia. These control room operators are just as important. Their jobs is just as important as the astronauts that go up to the space.
So I want to mention a few years back, ARC did a survey for an end user customer, a major refiner. And the major refiner wanted to find out, what is it that can make my operators more effective, right? And we in executing a survey like that, we went to a number of other end users and we talked to a lot of people and got their opinions so that we didn't bias with our own opinions, right? And it turned out that there was a lot of difference of opinion. Some people say procedural automation was good, and that's what we saw from Gilbert. You know, he really documented his procedure. There's an ISA 106 standard technically for procedural automation. But one of the top contenders, and I think it was the number one contender, was if you put instrumentation and control systems in, they make the operators more effective. All right. In fact, there was a story in an early Saudi Arabian refinery when an American company wanted to build a refinery in Saudi Arabia. The Saudi Arabian king said, "Oh, we have a lot of people here. We don't need any. We'll just put one man on every valve, all right? And we don't need automation, you know." And the obvious answer was, you can't run a refinery that way, all right? We will refuse to build this refinery there. I mean, that's kind of an exaggerated term. That's a way long time ago. But But when the control system is the most effective part of that automation process, you have to ask yourself what happens when it is gone. All right, and the most interesting accident where that occurred was the Fukushima Daiichi tsunami accident, where the electrical system was completely overwhelmed, and then you had a complete blackout. Right, and therefore the control room was black. They were literally going into the to the parking lot and taking batteries out of cars to power up instruments. So it does bring up the question, and here's where I'm leading to my question, is this: what about the training of the field operator? You know, at Fukushima, all you had was field operators at that point. You know, those control room operators, when they lost that display and all the displays went black, they lost a lot. They were in a very bad situation, and it shows us just how dependent we are on, and there is a great deal of effort to have backup power supplies, battery backup, redundancy, and there's a lot of great things, but from time to time. So anyway, I'm going to kind of ask my panel to comment on the training of the field operator.
Yeah, okay, so the training of field operator is also an important aspect, also the interaction with the control room operator. But I think there are actually some different aspects. So it's not so much about the high fidelity process model. It's really do I know where I need to go, which valve, which instrument is equipped, and do I know all the ways? And then we pretty much go a lot into that, what we have seen also with the 3D environments, virtual reality, and have realistic training scenarios there. We have seen something with HoloLenses, which are practiced. But to be quite honest, also from the discussion here, so we have to ask ourselves always, so we are pretty much dependent on energy. So if we just have a blackout and okay, you can say, okay, my smartphone, my iPads, I still have maybe some battery power to go to an instrument, but also the instruments, they need a certain power to typically work. So we don't just have manual valves and pumps, which you can just turn by hand and work with that. So I think it's an overall package, and also field operator training, also some evacuation scenarios for field operators is important. Just no round, and especially what we have done it for plants or like offshore rigs, which are just hard to get there, and where you actually have to hire a helicopter and to fly operators there to just get used to the surrounding. If you train it in a safe environment at home, it's much more efficient. But I would also like to build on the central aspect of the operator. We think this is also kind of crucial, and we think a lot about how can we even empower the operator much more. So one aspect is training. So we all want to have the pilots trained as best as possible, and don't train the hazardous scenarios which us on board. Should be the same for the plant operators, in my opinion, training in a training scenario and building on what Euro said. So it shouldn't just stop there with the training when the plant is up and running. It should be a continuous process. And even then think beyond the training. If you choose a simulator and choose a model, just think, what can I do with that also during the operations phase? How can I do it for increasing transparency to the operator to better know what's my internal state of that process? That can also help to really provide valuable inputs to the operator to even better and in a more optimal manner drive that production process and safely.
Gilbert, I also heard that you use a lot of DMC in your operators, dynamic multi-model predictive multivariable control, a lot of advanced control, and so the operators lose the feel of the process. Do you have any special procedures to train the operators how to run the plant if that DMC went away? And usually those operators want to say, I'm better than the controller, all right? A lot of them do, all right? And they're not always really better, all right? But they'd like to think they're better. And so, but nevertheless, there is still a valid concern that, obviously they had to they hadn't been through the startups, they hadn't been through certain catalyst activity changes, whatever. Do you have any special procedures within the Lyondell organization on how to keep the operators with the feel of the process?
Yeah, that's generated a lot of interesting conversation throughout the plant with, pros and cons. One side says, we designed these things to be up 5% of the time, so do we really want to focus on the 5% of the time it's not in DMC? But the reality is, like I said, there's operators out there that have never seen it run without DMC, so this is a case where the trail simulator would actually be pretty helpful, because if you really want to turn on your APC, some of these things generate quite a lot of profit. So the place to do that is in the OTSs.
Greg Fairwater, so are you saying you actually do run DMC on top of your simulator now?
No.
Okay. No. Because I get that question a lot. Sometimes they want to generate models from simulators itself for the DMC, and that's always a big debate as well, because the model doesn't necessarily match the plant and other things.
Yeah, we are having those discussions now, and Rick can probably address it better than I can. And how do we train operators on DMC in general? Because typically you train the people that are there, and then as they move on, the training doesn't necessarily carry over.
Just for the record, because this is recorded, I want to restate your question. The question was, do you use DMC on the training simulator itself? Obviously, DMC was used in the running plant, and the answer was no, they don't use it there.
Greg knows this as well as anyone. The role of the operator has changed over the years. It's gone from being concerned with controls to spending more time thinking about economics. So as long as you have that controller going, that multivariable controller going, you're doing really well. So what does the operator do? What is the role of the operator? The operator is there for taking over when the DMC controller drops out, to diagnose and find out why and put it back on, but also more importantly, to respond to abnormal situations. And how do you go about keeping those skills fresh and up to date? That's really a challenge. So this whole idea of either turning off the controller at times to allow the operator to interact with the process, or providing a simulated environment for the operator to continue to keep her skills up to date is very important.
Eddie, I agree with that. With respect to the operator, that's exactly right, what his role is. And I think the genesis of the question about DMC was in the context of operator training. But this sort of segues to, what else do you use the training simulator for, which may be a control engineer, or so that opens it up. Do you do it for code validation? Is it part of PID tuning? Is it a way to get models by the control engineer for a new controller design? So I guess I would just be curious, what other ways are DuPont and LyondellBasell using their custom training models besides operator training?
Yeah, we use them quite a bit, actually. The slide is not up there now, but we go all the way from early on when you're trying to design the process. So you have a model and you're trying to decide, are we going to use 2 columns, 1 column? Are we going to do this in batch, semi-batch, continuous? All those options are already available at that stage. Then you start moving on. Okay, you decide on a specific process. Now you have to start putting control strategies on it. That's what you were saying. So you start to say, should we use, what kind of controller should we use? What tuning should we use? Now, granted, the model is not the plant, but you will always, you'll be close. I mean, if the modeling is done right, if you have the right basic data behind it, by the time you get to the plant, you have a decent starting point. It might not be exactly the same thing, but it will be close. And then you keep going. I mean, then you get to the point of working with the vendor. They're trying to set up the the configuration that you have in your model, but now they have to put it in the DCS. And again, you work with the model to make sure that they do what you ask them to do. Ending up in the factory acceptance test when now you connect the model to their system to see if it does what it's supposed to do. At that point, usually there's the training of the operator, and then the last item that I had there is the one, the ongoing things. So now you have a model. The operators are trained. You may get new operators that show up. You can use the model to train them. But then something that I guess Matthias was implying here is now you have a tool. Now you have a model that you can use, for example, for inferential measurements. So the model will measure much more than what you actually measure in the plant. You can use it for optimization. If you put your model in some kind of loop on the side running parallel to the plant, you could have it also in some kind of supervisory role, in which the operators can see the plant in the HMI, and maybe on some other screen, the projection of the model, what will happen in the next 24 hours. So I guess that's what I was trying to tell you, that if you have the virtual plant, the model in the end, you will have much more than just an OTS. You'll have a tool that you can use quite a bit, actually. And we tried as much as we can, of course. I don't know if you've seen some of that.
I've seen some of that. But if you would just use it, for example, for control validation, so virtually commissioning the plant and doing operator training, to be frankly speaking, you have that continuously. So typically a process plant, it's like a living organism, it changes, I need to adapt controls and so on. I also want to check it before I actually implement that on a running plant. I maybe need to prepare for some kind of migration or some kind of implementation of a new control strategy. So I want to practice that before. Maybe in the time where I need to download to the new program, I have to run certain parts of the plant in manual mode. So I also can train for that. So I think the most important aspect is to keep your model up to date with the existing plant. And if you have that, it really unlocks a lot of additional possibilities and opportunities to really use that model-based technology.
I want to make a comment that I worked on a project in Venezuela for the Sincor refinery. All right. And that refinery was a brand new grassroots refinery, had a lot of cokers and taking the heavy, high sulfur oil from the interior of Venezuela and making it into a crude oil, actually, that they could sell, all right, because it had so much junk in it, very low API, very high sulfur. But in any case, they built this whole new project, and they bought a $5 million training simulator, right? And they used that training simulator to train all their new operators. And they had a whole room, building with all this control system equipment in it. And then after the plant finally got started up, that control system equipment was taken in for spare parts in the plant, all right, and completely thrown away. Nobody at the plant had the knowledge and expertise. I mean, they had hired a third-party company, a French company, I think, to build the simulator. It was a good simulator, but the plant never maintained it. And I think that one of the key questions I think that the end users have to ask themselves is, well, how is it that I'm going to have this digital twin maintained for life? That's exactly what Matthias is saying. And certainly those models had tremendous value when they designed the plant. They had tremendous value when you trained your operators. They could be used for real-time optimization, plant modifications. Those models are very useful for those. Obviously, very useful if you want to test a complex new control system before you actually implement it. Because when they make control system changes in a refinery, they don't reload the whole controller. They make those configuration changes online in the running process and hold that valve in manual while they reconfigure all the control blocks and functions upstream. And hopefully they got the right sequence so they didn't slam the valve open or shut, but in any case, it's a tragedy when you see a situation with that much money spent and no ongoing support and no planning from the overall And it's kind of a difference between the CAPEX, the capital expenditure of the plant, versus the OPEX. And your OPEX budget could very well find a very good justification for maintaining those simulators throughout the life of the plant.
Just a couple more points on follow-up is maintain those similar is important. If an operator looks at a similar and is supposed to represent his plant and there's a slight difference, that's what they're going to focus on. They won't get a lot of the knowledge. The other thing is location. The most successful similar I've seen is the one at our Houston refinery because it's in the control room. If you put it out there in a remote place, chances are it's not going to get used that much. So if you put it in right there where the operator is, I mean, they can get on in graveyards or whenever. And the other thing is you have to make it easy to fire up. It shouldn't take a half day to set it up.
Any more questions for our panelists or speakers?
I could just add one comment. So I think it's crucial really to get the operations guys their buy-in as soon as possible so that you don't fall into that trap that, okay, I build an operator training system once, spend from CapEx, and then I turn it over to the operations group, and the operations group gets a nice room with an operator training, and they didn't even know about that, and say, okay, now all are trained, let's use it as spare parts, and we got it for free. So things like that. So just get the buy-in as soon as possible from the operations guy and get them convinced and make it easy for them, you just said, to have access to it and see the value basically on a daily basis.
All right, I'd like to give our speakers and panelists a hand and thank you for attending. And